Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 7 video on the chapter of parallelograms, where I will discuss about rhombus, its properties, necessary conditions for a quadrilateral or a parallelogram to be a rhombus, and will solve a few problems on the properties of rhombus. If you have not watched the previous 6 parts video on the chapter of parallelograms, then I will strongly suggest and request that you please watch them also to maintain the continuity of your study of the chapter of parallelograms. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly or my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with part 7 video on rhombus on the chapter of parallelograms. Okay, so I have my rough notes prepared on the right hand side, where I will discuss about the rhombus and its properties, and finally we'll solve two or three problems. Okay, so what is a rhombus? We have already studied about quadrilaterals, parallelograms, and square, and also I think I have discussed rectangles. So what is a rhombus? A rhombus is a parallelogram where all the sides are equal. So basically it's a parallelogram, but additionally the conditions are that all the sides must be equal. So in this parallelogram ABCD is a parallelogram and it's also a rhombus. So we must have all the sides equal. Since it's a parallelogram, anyway, by the property of parallelogram, the opposite sides are equal and parallel. So AB is parallel to DC and AB is equal to DC. Also, we know that AD, the opposite pair of sides, AD is parallel to BC. But the condition of our parallelogram is that all the sides are equal. All the four sides of a rhombus are equal. So we have AB equal to BC equal to DC equal to AD. So this is the condition of a parallelogram which will make it a rhombus. So this is the basic core definition of a rhombus, that it is a parallelogram and all its sides are equal. Okay. And so obviously we have AB is parallel to DC, AB is parallel to DC, and we have AD is parallel to BC. Okay. Now once you have a rhombus, what are the properties of a rhombus? So if you are given a figure which is a rhombus, or if you are given a quadrilateral which is a rhombus, what can you say about its sides, angles, and diagonals? So the first thing is that all the sides are equal. So we have AB is equal to DC is equal to BC is equal to AD. So we must have AB is equal to BC is equal to DC is equal to AD. So in a rhombus, all the four sides will be are of same length, that is, all the four sides are equal. So this is the first property which comes from the definition of a rhombus based on a parallelogram. The second property is that diagonals bisect each other at right angles. This is super important. Diagonals bisect each other at right angles. So ABCD is a rhombus. If we draw the diagonals AD, BD, and AC, then let's say the two diagonals AC and BD intersect at the point O, then we must have the diagonals will intersect at right angles. and also the diagonals will bisect each other. Diagonals will bisect each other at right angles. Now diagonals will bisect each other. It is coming from the fact that it is a parallelogram. In any parallelogram, we know that the diagonals bisect each other. But additionally, if the diagonals intersect at right angles, for a rhombus, the diagonals will also intersect at right angles. So we must have AO is equal to OC, and also we will have OD is equal to OB. So we have AO is equal to OC, we have OD is equal to OB, and we have angle BOC is equal to angle AOB is equal to angle COD. All these angles will be right angle 90 degree or one right angle. Since the diagonals are the two diagonals AC and BD are intersecting at right angles at the point O. So we have this. This is a very super important property of a rhombus, that the diagonals bisect each other at right angles. The third property is that the diagonals bisect each angles of the rhombus. This is also very important. So diagonals bisect each angles of the rhombus means rhombus is a quadrilateral. So basically it has 4 angles. These are the angles of the rhombus: angle A, angle B, and angle C, and angle D. So when I am drawing the diagonal AC, the diagonal AC will bisect the angle A, and it will also bisect the angle C. Similarly, when I am drawing the diagonal BD, this will bisect the angle B as well as it will bisect the angle D. So what is happening is that if let's say the diagonals are intersecting at the point O. Let's say if the angle BAO, if this angle is x degree, then this will also be x degree, and if this angle is y degree, we don't know what is x and y, but if this angle is y degree, this will also be y degree. Also note that this angle will also be x degree, this will be x degree, this will be y degree, this will be y degree. Why? So diagonals bisect each angles of the rhombus. So we will have angle OAB should be equal to angle OAD equal to x degree. Let we don't know what is x, but these two angles will be same. Similarly, we will have angle. So this is coming from the fact that the diagonal AC is bisecting the angle A. Also, since the diagonal BD will bisect the angle B, we will have angle OBA should be equal to angle OBC is equal to angle y degree. We are assuming this, we don't know x and y, we are just assuming. Also, since angle A and C are opposite angles, we know that rhombus is essentially a parallelogram. Angle A will be equal to angle C. Angle A will be equal to angle C, and also we know that angle B will be equal to angle D. So the bisecting angles, the bisecting angles at both the vertices B and D, they will be same, that is y degree. Similarly, the bisecting angles at both the vertices A and C, they will be same, which is equal to x degree. Since angle A is equal to angle C, and the diagonal AC is bisecting the angle A, and the two bisecting angles are x degree, so the diagonal AC will also bisect the angle C, and each bisecting angle will also be x degree. I hope it is clear. Okay. So the main concept is that the diagonals will bisect the angles of the rhombus. Okay, so these are the main properties of a rhombus. Now let's see what is the necessary condition for a quadrilateral to be a rhombus. If you need to prove that a quadrilateral is a rhombus, what you need to establish? So if in a quadrilateral the diagonals bisect each other at right angles, then it will be a rhombus. Now remember that, so in any quadrilateral, if you find that the diagonals are bisecting each other at right angles, it will be a rhombus. Also, if so this was the condition for a quadrilateral to be a rhombus. Now what is the condition for a parallelogram to be a rhombus? You have a parallelogram and you need to verify whether it is a rhombus or not. So if you find that the diagonals are bisecting the angles of the parallelogram, then it will be a rhombus. So in a parallelogram, if you see the diagonals, if you see that the two angles that are being at every vertex of the parallelogram, the two angles that are formed by the diagonal, if they are equal, if those two angles are equal, then it will be a rhombus. Okay, and finally, what is the relation between a rhombus, a quadrilateral, a parallelogram, and square, and let's say rectangle? We have not studied kite. Also, we have not studied rhombus. We have not studied trapezium. So we will not discuss about kite and trapezium yet. So definitely, obviously, a rhombus is a quadrilateral because it has four sides. It's a polygon of four sides. So it's a quadrilateral. It's also a parallelogram because its opposite sides are the pair of both the pair of opposite sides are equal and parallel. Additionally, okay, so now a rhombus is not necessarily a square. Please note that in a square the diagonals are of equal length, but in a rhombus it is not necessary that the diagonals will be of equal length. The only condition a rhombus has is that it is a parallelogram and the diagonals are bisecting each other at right angle, intersecting at right angles. Now you can easily see that a square is also a rhombus. A square is a rhombus because a square, in the square also the diagonals are intersecting at right angles, and they are also and square is a parallelogram, Now additionally, a square has more additional properties, like all the angles are 90 degree. The only similarity between a rhombus and a square is that in a rhombus and square, they all both the figures have all the sides equal and they are both parallelogram. So this is the similarity between a rhombus and a square. And I will not talk about yet. I will not talk about how a rhombus is related to kite or trapezium yet, because I have not discussed about kite and trapezium. And definitely a rhombus is not a rectangle, because the angles of a rhombus are not necessarily 90 degree, but in a rectangle all the angles are 90 degree. And also in a rectangle, we know that the diagonals do not intersect at right angles. So definitely a rhombus is not at all similar to have a rhombus. The only similarity between a rhombus and a rectangle is that they both are parallelogram, and what else? They both are parallelogram. Yeah, that is the only difference, only similarity between a rhombus and a rectangle. Okay, So this was about the all the uh, geometrical concept about a rhombus, its properties, and the necessary conditions for a quadrilateral and a parallelogram to be a rhombus, and its relation with square, rectangle, parallelogram, and quadrilateral. Okay, now let's solve few problems. The first problem says that ABCD is a rhombus where angle BDC is x degree. Then which of the following is the measure of C? So ABCD is a rhombus, angle BDC is given. It is asking to find what is the value of, not value, it is asking to find the angle C in terms of x. So all the choices, you can see that all the choices are in terms of x. Okay. So what can we do? It is asking C. So C in okay. So we know that the diagonal, we know that BD bisects, the BD is a diagonal and BD will bisects the angle D. We know that a diagonal in a rhombus bisects the angles of the rhombus. So BD will bisect the angle, D. So this will imply that angle BDC will be equal to, we can say, angle BDA. Angle BDC and angle BDA are the two bisecting angles of the angle D, which has been bisected by the diagonal BD. Now clearly we can say this is equal to x degree. It is given in the figure, this is x degree. Now so we can say that x degree should be equal to x degree should be equal to half of angle D. X degree should be equal to half of angle D, since BD is bisecting the angle D. Okay. Similarly, we can say that BD bisects the angle B. So this will imply that angle DBC should be equal to angle DBA. DBA. Let's say this be y degree. We are assuming this to be y degree. So we are assuming this to be y degree. So this will be y degree and this will be y degree. So this will imply that y degree is equal to half of angle B. Now we also know that angle B and angle D, they are a pair of opposite angles in the rhombus, and they are equal. Since rhombus is a parallelogram, the opposite pair of angles should be equal. So angle B is equal to angle D. So this will imply obviously that half of angle B is equal to half of angle D. So this will imply half of angle B is y degree. So y degree is equal to half of angle D is x degree. So we have y degree is equal to x degree. So basically, y degree is equal to x degree. So this will imply that okay, fine. So we have y degree is equal to x degree. Now in triangle BDC, if we apply the angle sum property, we have x degree plus y degree plus angle C should be equal to 180 degree. So this implies x degree plus y degree we have found to be x degree equal to x degree. So we have x degree plus angle C is equal to 180 degree. So this implies 2x degree is equal to 180 degree minus we have so now we can say that 2x degree plus angle C is equal to 180 degree. So this will imply angle C is equal to 180 degree minus 2x degree. So angle C is equal to 180 degree minus 2x degree, which you can also write it as 180 minus 2x whole degree. So the correct choice is B. B is the correct choice. Okay, let's do problem number 2. ABCD is a rhombus whose diagonals intersect at O. Okay, if angle BDC is 50 degree and angle BOC is Q degree and angle OAB is P degree, then the value of P minus Q is, we have to find the value of the angle P minus angle Q. Now definitely, since ABCD is a rhombus, ABCD is a rhombus and diagonals AC and BD intersects at O. We know that in a rhombus the diagonals intersect at right angles. So we can say angle COB, which is equal to Q, will be equal to 90 degree. So Q is equal to 90 degree. Okay. And just from the example of the previous problem, we can also say that this angle will be 50 degree. This angle will be 50 degree. Now this problem can be solved in using various ways. So we have Q is 90 degree. We also know that since AB, we know that AB is this is 50, Q minus P. Okay, so now we know that diagonal BD bisects the angle D and B. Since we know that in a rhombus the two diagonals bisect the angles, so BD will bisect the angles B and D, and the diagonal AC will bisect the angles A and C. So this will imply that angle this will imply that angle BDC, which is given to be 50 degree, this is equal to half of angle D, okay, and which is equal to 50 degree. Also, we can say that we know that also angle DBC will be equal to half of angle B, because the diagonal BD is also bisecting the angle B. So, angle DBC will also be equal to half of angle B. Now, angle B and angle D are same. So, we can say this is equal to angle D, which is also is equal to 50 degree. So, angle DBC is 50 degree. So, this will imply that angle DBA will also be equal to angle DBC will be equal to 50 degree. This angle will also be 50 degree. Okay. Now, now we know that in triangle, we know that in triangle AOB, so Q is 90 degree. Q is 90 degree. So definitely we will have angle AOB will also be 90 degree, since the diagonals are intersecting at right angles. Okay. So in triangle AOB, if we apply the sum of angle property, so in a triangle the sum of the three angles is equal to 180 degree. So we must have angle the angle P plus angle AOB plus the 50 degree is equal to 180 degree. So this will imply P plus angle AOB is 90 degree plus 50 degree is equal to 180 degree. So this will imply P is equal to 180 degree minus 90 degree minus 50 degree. This is 180 degree minus 140 degree. This is equal to 40 degree. So we have found P is 40 degree and Q is Q was 90 degree. So therefore it is asking Q minus P. Q minus P is equal to 90 degree minus 40 degree, which is equal to 50 degree. Now you can also see, so this was one way of solving it. There are many other ways of solving it. Now since AB is parallel to DC, since AB is parallel to DC and BD is a transversal, and we know that one alternate angle is given, which is 50 degree, that is angle BDC. From that also we could have said that angle ABD is also 50 degree, since the alternate interior angles are equal in a transversal and cutting two pair of straight lines. And also see that the angle Q is an exterior angle to the two opposite interior angles of 50 degree and P. So we could have said that Q is equal to P plus 50 degree. From in the triangle AOB, Q is an exterior angle and the two opposite interior angles are P and 50 degree. So from there we know that an exterior angle is equal to the sum of the two opposite interior angles. From there we could have said Q is equal to P plus 50 and directly we would have got Q minus P. Q minus P is equal to 50 degree. So there are various ways of various methods or steps to solve a given problem. Okay, let's see the next problem. So the correct answer is, the correct choice is, so Q minus P is 50 degree. So the correct choice is D. Let's see the next problem. We have one more problem. Okay. ABCD is a rhombus whose diagonals intersect at O. Okay. BDC is A. So some angles are given. BDC is A, ACB is B, CAB is D, ABD is C, and DOC is E. What is the measure of the angle A plus B plus C plus D plus E? Now, first of all, the diagonals will intersect at right angles. Since this is a rhombus and the diagonals AC and BD are intersecting at the point O, so we must have E is equal to 90 degree. E is 90 degree because E is the angle, this is the angle DOC, and the diagonals BD and AC are intersecting at right angles at the point O. So angle DOC must be equal to 90 degree and the angle DOC is marked as angle E. So E is equal to 90 degree. Okay. What do we get? Okay, so what is angle? So BD, the diagonal BD, BD bisects angle D. So this will imply that the angle A is equal to half of angle D. Also, and BD is bisecting angle D. Okay, so we have angle A is equal to half of angle D. Also, BD bisects angle B. So this will imply that C is equal to the angle C, not the vertex C, but this is a small letter C. C is equal to half of angle B, since the angle B is being bisected by the diagonal BD. So we have this. Okay. Also AC. So this is the main concept, that the diagonals of a rhombus bisects the angles of the rhombus. So AC bisects angle A. So this will imply the angle D is equal to half of angle A. And also, and finally, AC bisects also the angle C of the rhombus. So this will imply B is equal to half of angle C. So we have got all the angles ABCD. Where is E? Oh, E is 90 degree. So we have the angles ABCD in terms of the angles of the rhombus. So this will imply that A plus B plus C plus D plus E is equal to what is A? A is half of angle D. What is B? B is half of angle C. What is angle small c? Half of angle B. What is D? D is half of angle A. And what is E? E is 90 degree. Okay, so we have this. Now from the first four terms we take half common and we get angle. After rearranging we get angle A plus angle B plus angle C plus angle D, and plus we have 90 degree. So this implies, now what is angle A plus angle B plus angle C plus angle D? It is the sum of the interior angles of a rhombus, which is 360 degree, because we know that in a quadrilateral the sum of the interior angles is always 360 degree. So we have half of 360 degree and we have plus 90 degree. So this is equal to half of 360 degree is 180 degree and we have 90 degree. So this is equal to 270 degree. 270 degree. 360 degree divided by 2 is 180 degree and 180 degree plus 90 is 270 degree. So the correct choice is B. B is the correct choice. So all these problems were heavily based on the fact that the diagonals of the rhombus bisect each other at right angles and also the diagonals bisect the angles of the rhombus. So this was all about the geometrical figure rhombus, its properties, its definition, its the necessary condition for a quadrilateral and a parallelogram to be a rhombus, and its relation with a parallelogram, quadrilateral and square. And we solved 3 problems based on the properties of rhombus. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The 2 other figures that are left to be discussed are trapezium, isosceles trapezium and kite, which I will do in the next 2 subsequent videos, and then I will solve the problems of 2 exercise given in the textbook of author RS Aggarwal. I will end the video here. Thanks for watching, and until the next video, take care and bye.